Now let's go to factors and multiples. Factors and multiples. Factors and multiples. Factors and multiples. Let's start with factors. The factors of a number are the numbers that can divide it without any remainder. For example, the factors of 20 are 1, 2, 4, 5, and the 20 itself. Note that 1 is a factor of every number and every number is a factor of itself. So let's now see how to write all of the factors of a number. Write, list the factors of Roman figure 1, 20, and Roman figure 2, 72. Let's go to the solution. Roman figure 1, 20. 20 is equal to 1 times 20, 2 times 10. You check 3, 3 cannot divide it, so you go to the next one, which is 4, 4 times 5, and that's all. So the factors are write the numbers from the top to the bottom here, and from the bottom up. That's 1, 2, 4, 5, 10, and the 20 itself. Those are the factors of 20. Now we go to the next one, which is Roman figure 2, 72. 72 is 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, 8 times 9, and that's all. So the factors are, start from the top to the bottom, start from the top here to the bottom, and from the bottom to the top. So that's 1, 2, 3, 4, 6, 8, 9, 12, 18, 24, 36. How about correct? 36 and the 72 itself. Those are the factors of, those are all of the factors of 72. Now, let's see how to find the common factors of a set of numbers. Common and also the highest common factor of all of the numbers in the set. Common and highest common factors. Highest common factors. What I mean here is common factor and highest common factors and highest common factor. There's just one highest common factor, but there'll be more than one common factor. So let's take an example. They call the highest common factor HCF. Find the highest common factor of Roman figure 1, 36, and 72. Roman figure 2, 25, 70, and 80. Roman figure 3, 64, 120, and 288. Now let me just make it 64, 120, 144. So let's go to the solution. We're not finding the highest common factor, we're finding the common factors. Find the common factors of 36 and 72. Find the common factors of 25, 25, 70, and 80. And find the common factors of 64, 120, and 144. We're finding the common factors, not the HCF. So the first one is 36. Let's write all the factors of 36. That's 1 times 36, 2 times 18, 3 times 12, 4 times 9, 6 times 6, and that's all 72. 72 is 1 times 72, 2 times 36, 3 times 24, 4 times 18, 6 times 12, and 8 times 9. So the common factors will be, there's a 1 here, there's a 1 here, 2, that's 1. There's a 2 here, there's a 2 here, 2, that's 2. There's a 3 here, there's a 3 here, 2, that's 3. There's a 4 here, there's a 4 here, 2, 4. There's a 6 here, there's a 6 here, 2, 6. There's a 9 here, there's a 9 here, 2, 9. There's a 12 here, there's a 12 here, 2, 12. There's an 18 here, there's an 18 here, 2, 18. There's a 36 here, and there's a 36 here, 2, 36. And that's all. That's all. So let's erase all of that. Now, what are the common factors? The common factors are 1, 2, 3, 4, 6, 9, 12, 18, and 36. Those are the common factors. And the biggest of them is the highest common factor. That means the HCF is 36. Now to Roman figure 2. Find the common factors of 25, 70, and 80. 25 is equal to, 25 is 1 times 25, and it's also equal to 5 times 5. 25, 70, and 80. 70 is equal to 1 times 70, 2 times 35, and what else? 5 times 14, and what else? 7 times 10. And that's all. 80. 80 is 1 times 80, 2 times 40, 4 times 20, 4 times 20, 5 times 16, 5 times 16, 5 times 16. What else? Will 6 divide 80? No. 8 times 10. And that's all. That's all. So the common factors are 1. There's 1 in all of them. 5. There's 5 here, there's 5 here, and there's 5 here. So 1, 5. And what else? 25. 25 is not common to all of them. So the common factors are 1 and 5. The common factors are 1 and 5. And the highest common factor is therefore equal to 5. Now let's take the last one. Find the common factors of 64, 120, and 144. That's Roman figure 3. 64 is equal to 1 times 64, and that's equal to 2 times 32, which is 4 times 16, and it's also equal to 8 times 8. Now to the numbers are 64, 120, and 144. 120. 120 is equal to 1 times 120, and is equal to 2 times 60, and is equal to 3 times 40, is equal to 4 times 30, and it's also the same as 6 times 20. 6 times 20, and it's also the same as, what else? 8. 8 times 15. What else? 8 times 15, 10 times 12. What else? And that's all. That's all. The third number is 144. 144. 144 is 1 times 144, 2 times 72, 3 times 28. 3 times 28. No, is that 3 times 28? No. 3 times 48. 4 times 26. That's correct. 4 times 144. Let's check that. Divided by 4. 4 here 1. 4 in 14 is 3. You are left with 2. 4 in 24 is 6. So that's 4 times 36. Don't be too sure. Make sure you work it out to get the correct answer. 6 times 144 divided by 6. 6 here 1. 6 in 14 is 2. 6 times 2, 12. 6 times 2, 12. You're left with 2. That makes that 24. 6 and 24, 4. That's 6 times 24. What else? 8. 144 divided by 8. Let's see. 144 divided by 8. 8 here 1. 8 in 14 is 1. You'll be left with 6. 8 in 64, 8. That's 8 times 18. 8 times 18. And what else? 8 times 18. And then we go to 12 times 12. Yes, 12 times 12. 12 times 12. And what else? That's all, 12 times 12. So let's see the common factors. The common factors are, there's a 1 here, there's a 1 here, and there's a 1 here. That's 1. There's a 2 here, there's a 2 here, and there's a 2 here. 2. There's a 4 here, there's a 4 here, and there's a 4 here. 4. There's an 8 here, there's an 8 here, and there's an 8 here. 8. There's a 16 here, there's no 16 here. So we're not picking 16. There's a 32 here, there's no 32 in the remaining 2. And that's all. That's all. So the common factors are 1, 2, 4, 8. 1, 2, 4, and 8. And the highest of them is 8, which simply means the HCF is 8. The highest common factor is 8. Now, let's see how to find the HCF. No, first of all, let's see what prime numbers are. Prime factors. Let's go to prime factors first. Prime factors. Now, prime factors are factors that are prime. That's the meaning simply. Prime factors are factors that are prime. And a prime number is a number which has only 2 factors. And those factors are the number itself and 1. 1 in itself. Those are the factors of any prime number. The number 1 in itself. The smallest prime number ever is 2. 1 is not a prime number because it doesn't have up to 2 factors. The only factor is that the only factor it has is itself. But a prime number must have 2 factors. So that's why 1 is not a prime number. But 2 is, because 2 has only 2 factors. Itself and 1. 1 and itself. Now let's see how to express a number as a product of its prime. Example. Express as prime product, Roman figure 1, 36. Roman figure 2, 64. And Roman figure 3, 125. Let's go to the solution. How do you write these numbers as a product of their prime factors? 36 express as prime product. 36, we start dividing by the smallest prime number ever, and that's 2. If 2 will not divide the number, you go to the next one, which is 3. If 3 will not divide it, you go to the next one, which is 5. And you keep going like that without skipping. 2 in 36 is 18. 2 in 18 is 9. It's 3 that will go now. 3 in 9 is 3. 3 in 3 is 1. And 36 as a product of its prime will now be 2 times 2 times 3 times 3. Now to the next one, Roman figure 2. Express 64 as a product of its prime. 2 will divide it. 2 in 64 is 32. 2 will still divide that. 16. 2 in 16, 8. 2 in 8, 4. 2 in 4, 2. 2 in 2, 1. So 64 as a product of its prime will be 2 times 2 times 2 times 2 times 2. How many 2s? 1, 2, 3, 4, 5, 6. That's 2 times 2 times 2 times 2 times 2 times 2. 1, 2, 3, 4, 5, 6. That's correct. So that's 64 as a product of its prime. Now to the next one, Roman figure 3. Express 125 as a product of its prime. 125. Here, 2 is the smallest prime number ever, but it won't divide this number. The next one is 3, it won't divide this number. The next one is 5, it will divide it. 5 in 125 is 25. 5 in 25 is 5. 5 in 5 is 1. So 125 as a product of its prime is 5 times 5 times 5. So that's how to express a number as a product of its prime. Now let's see how to find the highest common factor of a set of numbers using the prime product method. Example, find the HCF of A, 50 and 75, B, 36, 60 and 36, 60 and 100, and C, let's do 64, 72 and 144. Let's go to the solution. How do you find the HCF of these numbers? A, 50 and 75. We're going to write each of them as a product of its prime. Let's say that 50 as a product of its prime will be 2 in 50 is 25. 2 will not go anymore, but 5 will go. 5 in 25 is 5. 5 in 5 is 1. So 50 is 2 times 5 times 5. 75. What's 75 as a product of its prime? 3. 3 in 75, 25. 5 in 25, 5. 5 in 5, 1. That's 3 times 5 times 5. 3 times 5 times 5. So the HCF, which is the highest common factor, will now be equal to, there's a 5 here, there's a 5 here, that's 5 times, there's a 5 here, and there's a 5 here too, 5 times 5, and that's 25. So let's go to the next one. We'll take that out first. What's the next one? Find the HCF, question B. Find the HCF of 36, 60, and 100. 36, 60, and 100. 36, let's write that as a product of its prime. 2 here, 18. 2 here, 9. It's 3 that will go now. 3, 9, 3. And 3 in 3, 1. So that's 2 times 2 times 3 times 3. That's 36 as a product of its prime. Now to 60. How do you write 60 as a product of its prime? 2 in 60 is 30. 2 in 30 is 15. 2 will not go anymore. Go to the next one, which is 3. 3 in 15 is 5. 5 in 5 is 1. So 60 as a product of its prime is 2 times 2 times 3 times 5. Now to 100. 2 in 100 is 50. 2 in 50 is 25. 2 won't go anymore. You go to 3. 3 won't go. 3 won't divide that. You go to 5. 5 in 25 is 5. 5 in 5 is 1. So 100 is 2 times 2 times 5 times 5. Now, what is the HCF? let's check that. What's the HCF? The HCF will be equal to, there's a 2 here, there's a 2 here, and there's a 2 here. 2 times, there's a 2 here, there's a 2 here, and there's a 2 here. 2 times 2, there's a, okay, and that's all. So that means the HCF is 4. Now to the last one, which is C. Find the HCF of 64, 72, and 144. 64, 72, and 144. By using the same method, 64, if you do that, is 2 times 2 times 2 times 2 times 2. And 72, let's check that. 72, 2 in 72 is 36. 2 in 36 is 18. 2 in 18 is 9. 3 in 9 is 3. And 3 in 3 is 1. 72 is 2 times 2 times 2 times 3 times 3. And 144, if you check that, this is what you have. 2 times 2 times 2 times 2 times 3 times 3. That's 144 as a product of its prime. Now, the HCF. Now, let's say that the HCF is how going to be. There's a 2 here, there's a 2 here, and there's a 2 here. You pick 1, 2 times. There's a 2 here, there's a 2 here, there's a 2 here. Pick another 2. Times, there's a 2 here, there's a 2 here, there's a 2 here, times 2. What else? And that's all. That's all. So that means the HCF is equal to 8. And that's it, very, very simply. Oh, but before we go, there's an alternative method for finding the HCF. Let me just use it to do, let me just use it here. Find the HCF of 64. Find the HCF of 64, 72. Find the HCF of 64, 72. And you can use this long division method. 64, 72, and 144. We start dividing by the smallest prime number ever, but you make sure that it will divide all of them. 2 is the smallest prime number ever, and it will divide all of them. So 2 in 64, that's 32. 2 in 72 is 36. 2 in 144 is 72. 2 will still divide all of them. 16, 18, and here I'm going to have 36. Now 2 will still divide all of them. 2 in 16, 8. 2 in 18, 9. 2 in 36, 18. And there's no number that will divide all of them anymore. So the HCF will be, 2 times 2 times 2. And that is 2 times 2 times 2, which is equal to 8. So you can always use this method to find the HCF. And that's it. Very,